This is Algebra 1, Lesson 33A, Products of Prime Factors. We're going to do examples 33.1 and 33.2. What are the factors of 6? Now, we've talked about factors before. Factors you're going to multiply together. So a factor times another factor is going to equal your product. Okay, so we want things that when we multiply them together, we're going to get 6. So maybe it's 1 times 6, right? So usually the way I do it is I start with 1, and I know that's times 6. That's going to be your biggest factor. And then we try 2, and that would be times 3. And 2 and 3 kind of meet in the middle. There's not an integer between them. So we have just those 4 factors. Okay, so there's some words that you learn, some terms in this lesson, and we just discussed factor. What's a composite number? It talks about that in this lesson. Well, a composite number can be composed as the product of counting numbers. So 6 would be an example of a composite number, okay? Because you have more than just 2 factors, okay? More than 2 factors, okay? And then we've got prime numbers. Prime numbers are going to have exactly 2 factors. So if you think about the number 2, for example, 2 is equal to 1 times 2. It has exactly 2 factors, 1 and 2. Okay, you could do 3. 3 is a prime number because 1 times 3, it has exactly 2 factors. Let's back up for just a second. What about 1? 1 is equal to 1 times 1. Does it have exactly 2 factors? No, it has 1 factor. Okay, 1 factor, that is 1. And that 1 factor means that it is neither prime nor composite. Now, that's not mentioned in this lesson, but it's an interesting fact nonetheless. Okay, you could go to 4. 4 is 1 times 4 and 2 times 2, so it's composite. It has more than 2 factors. Now, they also talk about a prime factor in this lesson, and a prime factor would be factors that are prime. Okay, that seems kind of like, well, okay, let's look at what I mean here. Let's go back and look at 6. Okay, those are all factors, but which of them are prime factors? Well, the prime factors would be 2 and 3. Okay, so you're going to be using all of these different terms in this lesson. I think it'll become more clear as we go. So let's go on and look at another one, and we'll use some of those words as we talk about it. What are the factors of 12? We could go 1 and 12. We could go 2 and 6. We could go 3 and 4. And we've met in the middle. We have finished. Okay, so those are all factors of 12. 12 is a composite number. It is not prime because it has more than 2 factors. Now, are there any prime factors? Well, we know that 1's not prime. But 2 is, 3 is, 4 is not, 6 is not, 12 is not. So it has 2 prime factors, and those would be 2 and 3. So I could call those prime factors. Okay? Now, another way I think about the factors, prime factors, you may have seen this before, and that's a factor tree. Okay, so I'm going to break 12 down to, and you can do whatever you want, 2 times 6, 3 times 4. 1 times 12 is not really going to help me. So let's just do 2 times 6. And then what you do is you circle when you get to a prime factor. Okay, that's prime. It has exactly 2 factors, so I don't need to break it down to 1 times 2. That won't help. But 6 is composite, so let's break it down. It's 2 times 3. So you may have heard of prime factorization. We could say that 12 is equal to 2 times 2 times 3. Okay, that's actually coming up with a product that's equal to 12, not listing the factors. So this would be a prime factorization here. Okay, so these are all review concepts probably. Okay, so now let's look at how they're going to talk about it when you do your homework and tests and such. Here's example 33.1. Express 80 as a product of prime factors. Now, when the book does this, they do something called repeated division. And what they do is they only divide by prime factors. And then that way they can figure out what the prime factorization is. I'll show you what I mean, and then we'll do it another way, okay? Whichever way is more comfortable for you. So if we take 80, okay, and then I'm going to divide it by prime numbers. Now let's think of our prime numbers. We know 2 is, we know 3 is, 5 is, 6 is not, 7 is, okay, and it keeps going. And we may need a bigger number in a minute, but we'll keep going if so. Let's see, that'd be 8, 9, 10, 11's a prime, okay, and we could kind of keep going. All right, so what we're going to do is just divide by things that are prime. Okay, now we're going to go with 80 and we're going to just to go ahead and divide it by 2. So let's divide it by 2, and that's equal to 40. So we can see that 2 is a prime factor. Let's divide it again. Let's divide 40 and we can just keep dividing it by 2. That's 20, right? Now let's divide it by 2 again, and that's 10. We can divide it by 2 again, and that's 5. Now, our prime factorization, since we just divided by prime numbers, we would say that that is 2 times 2 times 2 times 2. I got it here, 1, 2, 3, 4, and then times 5. Okay, so here's a list of prime factors. That's the prime factorization. And you can check it like this. 2 times 2 is 4, times 2 is 8, times 2 is 16, and 16 times 5, if you work it out, is 80. So we know it's right. They're all primes that when you multiply them together, you get 80. Personally, I have to really kind of think about it to do it this way because I have been for a very long time doing this with a factor tree. And with a factor tree, you don't even have to just do it by divide by primes. You can do whatever. Like here, you see it ends in 0, so you could say 8 times 10, and then just keep breaking everything up until you get to primes. I personally like this method easier. I like it more. I feel like I mess up less, but you might like the repeated division method that the book teaches. And you can see here we get the same answer. We got 2 times 2 times 2 times 2 times 5. Okay, and you would just write that out like we did just a minute ago, and it's the same. The method really doesn't matter as long as you are getting the correct answer and it makes sense to you. So you can choose. All right, 33.2. We're going to do one more with a different number. Express 147 as a product of prime factors. I'm going to do it the factor tree method, but really you could do it either way. All right, so for 147, we still, no matter which way we do it, we got to think about what are some factors so we can begin to break this down. Now, I like to use my divisibility rules, and I know that if a number is divisible by 2, it will be even. And you can see this ends in 7, so it's not even. So we know it's not divisible by 2. Divisible by 3, if you took Saxon 8-7 last year, you learned that if you add these digits up, 1 plus 4 is 5, plus 7 is 12, and you get a number that is divisible by 3, then the number is divisible by 3. So that means I know 147 is divisible by 3. So I can go over here and do a quick little long division and see what that other factor is. Maybe you knew that one off the top of your head. Makes sense now, right? Because 350s would be 150, and so 349s would be 147. Whoops, I started to put 47. There we go. Now 3 is prime, so I'm going to circle it. I can break 49 down. That's 7 times 7. And now I have all prime factors. So my prime factorization is 3 times 7 times 7. And you can multiply that out. 3 times 7 is 21, and 21 times 7 would give you 147. So that'll work.